Module 4, Lesson 25, Finding Solutions to Make Equations True. So in the last lesson we were looking at inequalities, looking at all kinds of stuff. Today we're just going to be looking at making equations true. And the number that we substitute for a variable to make an equation true is called a solution. So I can use substitution to determine whether a given value makes an equation true. I can stick a number in, follow the order of operations, and say this equation is true for this number, or this equation is false for this number. I can show and explain that the solution to an equation is the value that replaces the variable to make the equation a true number sentence. So identify a value for the variable that would make each equation or inequality into a true number sentence. And this is a review from lesson 24. So hopefully, I know that was a long lesson, but hopefully you took the time to really get it down, because it's going to make this lesson and the next lessons much easier. So what could I put in? And you'll remember that I used a balance beam. In the last lesson, I've got 15 on one side and I've got 3 plus g on the other side. So if I want to discover the identity of the g, I'll take off the 3, and then I'll have to take off 3 on this side, and I will find that g is 12. 3 plus 12 equals 15. Now, of course, the question is 12 the only possible answer? We found 12 as a possible answer. Is it the only possible answer? And the answer is yes. If I put in any other number for the letter G, this number sentence will not be true. And then I'm supposed to state when the equation or inequality is true using symbols. So 12 is the only value of G that will make the equation true. So right here, I've answered that part. The equation is true when G equals 12. I have stated when the equation will be true. All right, you'll remember in the last lesson I talked about we scale down on these. We did lots of these kind of examples here, and we said if I've got 30 on one side and I've got 2d on the other side, if I want to get just down to the d, I have to divide by 2. And over here I have to divide by 2. So I've got d and I've got 15. But d is supposed to be less than 15, because we are doing an inequality here. So d is less than 15. Now I've figured out when the equation is going to be true, but I need to stick some numbers in here and see what happens. So what happens when I put in a 1? Well, that's going to give me 2. Well, 2 is definitely less than 30. What happens when I put in a 5? Well, that gives me 10. Well, 10 is definitely less than 30. So looking at our statements here, there is more than one value of d that will make the inequality true. And the inequality is true when d is less than 15. Or you could say 15 is greater than d, but most of the time in math you're going to see it expressed with the variable first and then the inequality symbol. All right, so I've got 15 divided by f, so thinking of my little balance scale here, I've got 15 divided by f, and I've got 5, and I want this to be less than 5. So if I want the identity of f, maybe I'm making this one way too hard. So 15 divided by a number is going to be less than 5. Well, I know that 15 divided by 3 is going to be 5. And so 15 divided by 3 is not less than 5, so 3 doesn't work because it's not less than 5 there. Because 5 equals 5. So what happens when I do 15 divided by a bigger number? What happens when I do 15 divided by 5? Is that going to be less than 5? 15 divided by 5 is 3. 3 is less than 5. Ooh. Ooh. Now, so just a little bit of logic here. So first thing I did is I used the number 3, and I found out that 5 was equal to 5. Well, that wasn't less. So then I tried a number greater than 3 over on this other side, and it came out true. So I'm hearing that I picked a number greater than 3. So I started here with 3, and I had 5 was equal to 5, but I was supposed to be less than 5. So then I picked a number greater than 3, and my number sentence, my inequality, became true. Nice. What happens if I pick a number less than 3? What if I do 15 divided by 2? Well, I'm going to get 7.5 is less than 5. It's not going to work. So if it is equal to 3, it's false. If it's greater than 3, it's true. If it's less than 3, then it's false. And these values right here are for f. If I have f be equal to 3, my inequality is false. If I have a number greater than 3, my inequality is true. And if I have a number less than 3, my inequality is false. Now hopefully that looks somewhat familiar from yesterday, well, the last lesson. All right, there is more than one value of f that will make the inequality true. The inequality is true when f is greater than 3. And I just did a big long explanation of that. All right, a number, so same thing. So I need to stick something in here that will make it true. So I've got 42 is going to be less than or equal to 50 minus m. Now I'm pretty certain it was in lesson 24 that I said let's replace this inequality symbol and let's just stick it in as an equal sign. And then we can use some identity information to help us figure out what m could be. So I've got 42 over here, and I've got 50 minus m, and the question is, what would I have m be to make things equal? Oop. There we go. Oh, horrible handwriting today. Or my smart panel's not behaving very nicely. Maybe it's just the panel. All right, so there is a number that if I subtract it from 50, I'll get 42, which means there is a number that if I add it to 42, it will be 50. Thinking about my math mountains and fact families. So I could then, well, I could take the 42 away off this side and take the 42 off this side, and I'm going to find out that my number is 42. Okay, so what happens when I have, becomes 42, becomes 8. That's a little better. Okay, all right, so let me think here. If I've got 42 is less than or equal to 50 minus 8, is that true? Well, 42 is less than or equal to 42. It's a true statement there. So what happens if I pick a number greater than 8? And at this point it should be starting to sound really familiar compared to yesterday's lesson. So pick a number greater than 8. 42 is less than or equal to 50 minus 10. 42 is less than or equal to 40. False. So I picked something that was greater than 8 and it did not work. Equal to 8 did work. So what about a number less than 8? 42 is less than or equal to 50 minus 5. So I picked a number less than 8. 42 is less than or equal to 45. True statement. So this is true in two situations. If I pick a number that is equal to 8 and if I pick a number that is less than 8. So there is more than one value of m that will make the inequality true. The inequality is true when m is less than or equal to 8. Alright, so that was a huge review of stuff from yesterday, but now we're going to work on what we're doing today. So each of the following numbers, if substituted for the variable, makes one of the equations below into a true number sentence. Match the number to that question. So I have 5 numbers to pick from, and I am going to substitute those 5 numbers in and make each of these a true statement. And I'm only going to use each number one time. So really this is kind of a matching activity here. What can I add to 26 and get 32? Now I could just randomly start sticking numbers in here and see what happens. I mean, I could just stick a 3 in here. 26 plus 3, 29. Okay, that didn't work. 26 plus 6, 32. Okay, so it's 6. All right, I could do that if I had no other choice. But I'm going to look at these and I want to try and use just a little bit of number sense. For example, if I look at B, I have a number that if I decrease it, I get to 32, which means I have to have a number greater than 32. So as I look at my list here, well, 44 is the only one that I have that's greater than 32. So instead of just randomly trying numbers, I'm going to start with 44. 44 minus 12, and I'm going to show my work here. 32 equals 32. Okay, so this is going to be 44 here. And I showed some work showing how I came up with 44. All right, well, let's see here. I've got a number that if I divide by 3, I get a whole number. I get 5. Which means I need to be looking at a number up here that is divisible by 3 and divisible by 5. There's only one number that is divisible by 3 and by 5 up there, and that's 15. So I can check it. 15 divided by 3, 5 equals 5. 5, check. Yep, substitution, stuck it in there. Now, here's the substitution part. You have to stick the number in and actually perform the operation. I replaced the variable with the 15 and then I performed the operation. That is substitution. Stick the number in there and actually follow the order of operations and see if it comes out true. All right, so let's see here. So I've got, oh, this is a nice one. I've got 4 raised to the power of 2, or 4 squared, is going to be equal to a number. So all I have to do is know that 4 squared is 4 times 4, and that's 16. If I put 16 in, is this statement true? Yes, it is. Awesome. So here's 16. Okay. Well, we've already figured out, with my guess and check method, I figured out 6 plus 26, which only leaves me then with 17 times 3. But have I done my check? And the answer is no. I have to substitute. 17 times 3 is 51. Now I have substituted and checked my answer. Part A, 6 plus 26, and I'll probably write that vertically because for some reason my brain likes that. Okay, here is substitution, sticking the number in and actually performing the operation. So we're going to use substitution today. All right, quick little discussion here. In lessons 23 and 24, we discovered that when working with equations that have one variable, there was only one number that could make the equation true. The number that we substituted to make the equation true is called the solution. The one number to make an equation true is the solution. So in the example above, 6 is a solution to n plus 26 equals 32. And that was the examples we just looked at. 44 is a solution to n minus 12 equals 32, and so on. And each of these, because they are an equation, has one number to make the equation true. Now, as you explore farther in math, you'll start to see that there are lots of different ways to express that number using absolute value and things like that. But in the end, we're back to one number. All right, so in class, we actually have a matching game that you would be doing. And you would work with a partner to match up equations with their solutions. And there is a link to the matching game in the lesson materials if you want to do that. If you are going to play the game, then I suggest you pause and play the game and then come back to the video. But there are 20 equations which we are looking for true solutions for. At least I think it's 20, maybe it's not 20, it's a lot. But here are all the solutions that they gave us in the matching game, and we need to match them up with all of these equations. And once again, I want to think kind of logically about this. I want to have a strategy. So, on this first one here, we did identities clear back in lessons 1, 2, 3, and 4. So I know that I have A plus 14, and if I subtract 14, that will leave me with A. And thinking about my balance beam here, if I had A plus 14 is 36, and I take away 14, then I have to take away 14 over here, and A is going to be 22. Looking at this next one here, 24 is equal to E plus 11. Oh, wait a minute. I forgot to do something. I forgot to use a little substitution here. I have to stick in my number here. I said it was 22. 22 plus 14 is 36. Check. Okay, it's good. I have used substitution to check my thinking. So I'm going to need to use a number that is less than 24 on this problem. And I have already used the 22. So I've got 9, 8, 3, 16, 15, 13, 5, 2, 7, 1, and 19. Boy, that's a lot of them. Well, I know that 11 is less than half of 24, so I'm going to need something more than 11. So 16 is there, 13, 19. I've got three choices. Well, let's see, 16 plus 11. Well, that's 27, so no, 16 doesn't work. I've got 13. 13 plus 11 is 24. There we go. So I'm going to use 13 on that one. Okay. A number divided by 5 is 3. So I know that I'm looking for a number that is a multiple of 5 and of 3. Well, that's not 5s, and that's not 5s, that's not 5s. Okay, now looking here, this is a multiple of 5 and 3, and this is a multiple of 5 and 3, and none of the rest of them are multiples of 5 and 3. So is 60 divided by 5 3? Well, 60 divided by 5 is 12, so I don't think that's going to work. But 15 divided by 5 is 3. Yes, that will work for me. Okay. All right. Let's see here. So I've got 45, and I'm going to divide it by a number, and I'll get 9. So 45 divided by something is going to come out as an even number. So it needs to be a number less than 45, obviously. Well, let's see, 45 divided by 9, but that doesn't divide evenly. 45 divided by 27, that's not going to divide evenly. 45 divided by, no, okay, 45 divided by 8. Nope, 45 is not divisible by 8. 45 divided by 60, well, that's not going to work. 45 divided by 3. 45 divides by 3. 45 divided by 3, but that gets me 15. Well, that's a little bit big. I need to get a little bit smaller, so I probably need to pick a number greater than 3, which is about every other number on here. Okay, so let's see. 45 divided by 26, that's not evenly going to divide. 45 divided by 16, no. 45 divided by 54, no. 45 divided by 13. 13 times 9, no, that's not going to work. 45 divided by 5. Ah, there we go. 45 divided by 5 is 9. Okay, there we go. All right, so we have used, off of this page, I've used the 22, I have used the 13, I have used the 15, and I have used the 9. No, not the 9, the 5. Okay. Now some of these you might look at them and you might just know the answer. Make sure that you still substitute and check. Don't just say that's the answer. Put the number in there, perform the order of operations, check your work. This one's nice. I've just got 1 5/10 plus 5/10. Well, that's pretty easy to get a 2 there. Okay. Let's see, 56 divided, see this is nice too, 56 divided by 8, that is 7. 56 divided by 8 is 7. There's my little check, 7 is M. Okay. And of course, if I were being really picky here, I would make sure that I have equal signs here. M equals 7. Okay. Woo. This one does not look fun. I think I'll come back to that one for a minute. Oh, this one looks like a math fact I've memorized. 63 divided by 9. Okay. 63 divided by 9 is 7. So, yes. R equals 9. Check. It works. Yay. Hooray. Oh. This one doesn't look so bad because the 3/4 are going to cancel each other out. So I've just got a number plus 13 is 32. Oh, well, that's not bad. And I could use my fact families, 32 minus 13, and find out I've got 19. So 19 plus 13 and 3/4, well, that's just the 3/4 there, and 32. So P is equal to, dragging things around here, P equals 19. All right. We keep going here. Oh, but I used up that 7 too. Oh, love this one. 3 times 3 times 3. 9 times 3 is 27, is 27. So, yeah, that works. B is 27. If I put a 27 here, this sentence is true. Oh, another multiplication fact family here. 4 times 8 is 32. Check. So F equals 8. Okay. D minus 10. So I've got an, well, if I took 10 away from the number, if I add 10 back, I get back to the number. So what happens if I put in 42? Oh, D equals 32. 32. 42. There is me simplifying. So I put the 42 in, subtracted the 10, got the 32. So I can say that D is equal to 42, and I have checked it by substituting in. There we go. So there's going to be a number greater than 43 that I decrease by 17. Let's see here. I probably ought to cross off some of these that I've been in a big hurry and used. Well, if I need a number greater than 43, I've only got 2 choices left. I've got 60 and 54. Well, let's start with 60 first. 60 minus 17. 43 minus, sorry, 60 minus 17 is, it's true. All right, so H is equal to 60, and I know that because I substituted it in and performed the operation. Okay. Ooh. Oh, once again, they've got the variable all by itself for me. So I've got a number times 1/3. 9/3 is 3. So I'm going to say that K is equal to 3. And I proved it by substituting the 3 in for the k. 4 is 1/4 of a number. Well, that means it's got to be less than one of these. 1/4 of a number means if I divide it by 4, 16. 4 is equal to 1/4 of 16. Well, I need to do the 16 times 1/4. So 1/4 times 16 is 16 over 4, which is 4. So I have checked. My Q is equal to 16. I checked it by substituting. Once again, they give me the variable all by itself. That makes these really easy. I just have to do this over here. So 35.5 minus 9.5, and that gives me 24. My number is equal to 24. If I really wanted to check it, I could take 24 and add 9.5 to it, and I'd get the wrong answer. Oh no, I did that one wrong. Sloppy subtraction. Let me try that again. 35 and 5/10 minus 9 and 5/10. 15 minus 9 is 6. There we go. 26. Oh, good. 26 is on my list. Okay. So I've substituted in the 26 and said, yes, it's true. So there's a number that I take away something and I get 45. And I have to take away a lot of something because 99 is almost twice as big as 45. I don't think subtracting 16 is going to work. And I already used the 16, so what does that leave? Oh, that just leaves me with 54. 99 minus 54. Okay, U equals 45. And I checked it by substituting it. Except U doesn't equal 45. I'm really having a rough time on this lesson. U is equal to 54. The number that I put in for U is what U is equal to. All right, so looking at the equation, 8 times the number is equal to 72. We know that 9 is a value that we can substitute for n that results in a true number sentence. So even though I kind of bumbled and fumbled my way through the matching game, what matters here is that you can say what number will make this number sentence true. Because it is an equation, there is one number that I can substitute in and make it be a true statement. So in previous lessons, we described this solution as the equation is true when the value of n is 9. And we noted that the equation is false when any number other than 9 is substituted for n, or when n does not equal 9. Therefore, there is only one solution to 8n equals 72, and it is 9, and we would express that as n is equal to 9. When we talk about what is the solution to an equation, we state the variable, and we say it is equal to, and we say what value it is equal to. N is equal to 9. That is the only time this equation is true. We also saw that both statements, in other words, the numbers that make the equation true and the numbers that make it false, can be summarized with one sentence. The equation is true when n equals 9, and I just went on about that, because the values that make n equals 9 true or false are the same as the values that make 8 times n equals 72 true or false. This statement here has the same meaning as this statement here, and we looked at that a lot in lesson 24. We can represent the solution as the solution is 9 or n equals 9. The two ways we can write and say this equation is true when the solution to this equation is. All right, quick little lesson summary here. We talked about variables. Variables are symbols such as letters that represent a number. A variable is a placeholder for a number. It doesn't vary. We've got expressions where we're performing operations. We've got numerical expressions that happen when we replace the variable with a number. Equations are statements of equality. They use the equal sign. If a and b are two expressions in the variable x, then A equals B is an equation in the variable x. Alright, so looking at the I-CAN statements, I can show and explain that the solution to an equation is the value that replaces the variable to make the equation a true number sentence. The big point was we could take numbers, put them in, and say it's true in this situation. Alright, learning target, I can use substitution to determine whether a given value makes an equation true. I can stick numbers in, perform operations, and say it is true when this happens. Alright, so that concludes Module 4, Lesson 25. The matching game at school is really fun. I don't imagine this lesson online is going to be tons of fun, but do the best you can. Remember, the big idea is that we can take a number, substitute it into the equation, and decide if the equation is true for that number. Make sure you complete your exit ticket, and if you've got questions and need help, reach out to your teacher.